Okay, so there are 5 ways or 5 different theorems that we can use to prove that they're a parallelogram. So both pairs of opposite sides are parallel, then it has to be a parallelogram. If both pairs of opposite sides are congruent, it has to be a parallelogram. If both pairs of opposite angles are congruent, it's a parallelogram. And if the diagonals bisect each other, it's a parallelogram. So those are just your properties from the parallelogram song. But there's one more that's convenient for our proofs. If you can prove that one pair of opposite sides is parallel and that same set of sides is also congruent, then you can also prove it's a parallelogram. So we've got 5 different ways of determining if it is a parallelogram or not. So first, we are just going to practice looking at some pictures and determining if we have enough information to decide if these quadrilaterals are parallelograms or not. So for number 1, based off of the information we have in the picture, opposite sides are congruent, which, yes, that is enough information to prove that it's a parallelogram. And for the reason, I'm just going to write opposite, I'm going to abbreviate OPP, opposite sides congruent. Use my little congruent symbol there. All right. For number 2. Number 2, we would need to solve for that missing angle. By the way, quadrilaterals always have 360 degrees on the inside. Like triangles have 180, quadrilaterals have 360. So real quick, go ahead and solve for this missing angle. Let's see what it is. And you get 45, right? Which means opposite angles are congruent. And so yes, that's one of our ways we can prove a parallelogram. So opposite angles are congruent. And let's see, number 3. Aha, it's your favorite parallelogram property, diagonals bisect. So yes, it is a parallelogram because diagonals bisect. Okay, I'm going to let you guys discuss number 4 with your group before I give you the solution.
Wait, why?
I can't be bothered right now. Yeah, I will.
But how do we know they're parallel?
Number 5 is also
Is that not bad?
No.
Or no?
Well, hold on a minute, I don't know.
I think it's parallel.
No.
Is it parallel?
Alright, so we have one pair of sides, one pair, and it's a pair. Yeah, so it's good.
That isn't me. This is the diagram.
You didn't read it.
I read it, and then I promptly clicked clear.
I think that's similarity to parallel.
Oh, actually, yeah,
Oh,
that's the transversal.
Yeah.
Okay, real quick on number 4, what do you guys think? Yes or no?
Yes.
It is yes. Anybody have a good reason?
Number 5.
Right, the opposite sides are parallel and congruent, but how do we prove, I mean, these sides are marked parallel, congruent, sorry, but how do we prove they're parallel? Leo. The angle, what does the angle do?
Well, the angles are the same, so in theory it should be parallel.
Anybody remember the name of that? Yes.
In alternate interior angles convex.
Yeah, so these guys are alternate interior angles, and on your purple toolkit, the alternate interior angles converse says that if alternate interior angles are congruent, the lines attached to them must be parallel, which makes these guys parallel, which makes it a parallelogram. So I'll say opposite sides, congruent, and parallel. Or, yeah, one set of opposite sides. So that's a good thing to keep in mind. You may need to pull out your angles converse theorems in some of the proofs that we do for parallelograms. All right, number 5. What do you guys think about this one?
I think
hearing mostly no's. You would be correct. So because of these angles that are marked with the little 1 angle mark, you could prove that the lines on the left and right are parallel, but we don't have enough information to prove that the lines on the top and bottom are also parallel. So not quite enough information yet. And for number 6, what do you guys think?
Yes. They're parallel.
Because it's parallel.
Actually, no, they're not congruent though.
So what do you guys think? Yes or no? I got a mixture there. This one's no.
Okay,
So we just don't have enough information yet, right?
If we knew the sides
Good
were
job.
parallel,
Good job.
So for this one, if I knew that the left side and the right side were also parallel, then that would fix it, right? Or if I knew that the top and the bottom ones were congruent, that would also fix it and make it a yes. But since we don't know that, it's a no. We don't have quite enough info yet. Okay, so let's go ahead and write some things down on your toolkit, and then I'm going to give you a crash course through proving stuff.
Yeah, so it's a big line. You know, there's only
All right, let's see. We have 7 total things we're going to add to this, and then that's the completion of your toolkit. Wild. All right, so on the left side, remember that you have like your definitions and things, and the right side are your reasons. So first one that we'll add is we'll say opposite sides are parallel in a parallelogram. And instead of writing parallelogram, I'm going to do a little shortcut and draw a picture because parallelogram is a long word. So opposite sides are parallel in a parallelogram. And so you can use this guy in 2 different ways in your proof. You might need to use it as a parallelogram property. Like maybe you're given a parallelogram and you want to use the fact that opposite sides are parallel for something. Or you might want to use it as a way to prove that the parallelogram you're looking at is a parallelogram. So, or you can use it to prove that you have a parallelogram. And guess what? We're going to go ahead and do that for the other properties too. So the other 4 properties of the parallelogram jam. So we'll do opposite sides are congruent in a parallelogram. And this is also can be used as a parallelogram property. Or you could use this to prove that what you're looking at is a parallelogram. Same thing for opposite sides. Oops, no, opposite angles, sorry. Opposite angles are congruent in a parallelogram. And same thing, you can use this as a parallelogram property. to help you prove something else, or you can use it to prove that what you're looking at is a parallelogram. All right, and then the last one, like this one, is diagonals bisect. So, diagonals bisect, I'll say bisect each other in a parallelogram. And same things, you can either use it as a parallelogram property or you can use it to prove that you have a parallelogram. And by the way, just keep in mind that like all these things that we're looking at here, like on the left side, that's what you would essentially like write down in your proof. So like in our T-charts, we'll write things down like diagonals bisect each other in a parallelogram on the right side of our T-chart. So it's kind of wordy, but it works. All right, so next one, we're gonna do the one set of opposite sides are parallel and congruent, because that was our fifth way to prove you have a parallelogram. So we'll do one set of opposite sides are parallel and congruent. And this one we just use to prove that what you're looking at is a parallelogram. Okay, and then let's see, two more. So you can use the properties, of course, also like of a rectangle, rhombus, and square too. So let's say like you're given a rectangle and you want to use the fact that opposite sides are congruent. Well, a rectangle is a parallelogram, so you can still just use that parallelogram property of opposite sides are congruent. But the rectangle has a special property of its own too, right? So a special property that we will use of a rectangle is that all angles are right angles. And that is a good old rectangle property. Same thing for the rhombus. The rhombus has some special properties too. The one that I find to use most common, so I'll write it down here, is that all sides are congruent. And that is a rhombus property. And that's the completion of your proofs toolkit. Congratulations. Amazing. Okay, back to notes. So, parallelogram proofs are often going to include a little triangle proof in there. So, just a quick refresher on triangle proofs. Let's see, I'm going to try and figure out, can I draw you a picture? Well, remember that in triangles, like let's say we just proved that the triangle on the left and the triangle on the right in my little picture here are congruent. So remember that after you prove that two triangles are congruent, it makes sense that each like angle has a matching angle that's also congruent, right? And that each side is congruent to another side in the other triangle. Do you guys remember the name of what that is?
CPC.
Yeah, CPCTC. So corresponding parts of congruent triangles are congruent. Okay, so proving that triangles are congruent is going to then let us use CPCTC to prove other things like sides are congruent. And that's going to be helpful because remember, some of the easiest ways to prove that we have parallelograms are that proving that sides are congruent or like parallel or things like that. So we'll get those congruent pieces or we'll get like congruent angles from proving that triangles are congruent most of the time. So with that said, let's jump in. So on the first one, given that QR is parallel to PS and angle P is congruent to angle R. Okay, so we'll just look at the picture first and make a game plan, and then we'll write stuff in our proof. So I'm just going to highlight my parallel lines first and mark the angles that it gave me are congruent. Okay, and let's just go ahead and mark the other stuff that we already see, and then we'll decide if we have enough information to prove it's a parallelogram or if we need to keep thinking. So what else do you see in this picture that we could just go ahead and mark? A reflexive side, for sure. What else? Yeah, alternate interior angles. We can mark those for sure. Anything else? Yeah, I don't necessarily see anything else either. Do you think this will be enough information to prove that we have a parallelogram? How could we use these pieces to prove that? Do we have enough information to prove the triangles are congruent? Yeah, what theorem would we use for that? Angle, angle, side, right? Okay, so once we prove these triangles are congruent by angle, angle, side, we have the top and the bottom are already parallel. We could say that the top and the bottom are also congruent, right, by CPCTC, and then we'd be done because we have a pair of opposite sides that are parallel and congruent, and that would be enough to prove it's a parallelogram. So that will be our strategy. So now let's write it down. So I was going to draw my t chart and write in my givens. All right, so the first thing we marked was that QS is congruent to itself by the reflexive property. The second thing we marked were those alternate interior angles, and we'll use 3 letters to name those guys. So we can do RQS for one of them. So angle RQS is congruent to PSQ. Yep. And that's because they are alternate interior angles. And then we decided that was enough to prove our triangles were congruent. So in our next step, we can go ahead and say triangle, I'll say PQS is congruent to triangle, and we want to do the same order. So let's see, PQS would match RSQ. So triangle RSQ by angle, angle, side. Okay, and then after that we said we need to prove that the sides that are already parallel are also congruent. but we can do that with CPCTC. So we can say QR is parallel, oh, not parallel, what am I thinking? Congruent, sorry. QR is congruent to SP by corresponding parts of congruent triangles are also congruent. So now that we have a pair of opposite sides that are parallel and congruent, voila, we have a parallelogram. So PQRS is a parallelogram. And our reason will be that we have a set of opposite sides that are congruent and parallel. Okay, what do you guys think? Questions? Okay, let's try one more together, and then I'll let you guys try one on your own, and then that's the end of our notes. So this next one, notice that in this next one, we're asked to prove that a segment is congruent to another segment. So you're not always going to be proving that you have a parallelogram. So in this case, we're just going to be using properties of parallelograms in order to prove what it's asking. So what we're given that PROE is a rhombus, and we're given that angle SPE is congruent to angle VOE. And we want to prove that SE is congruent to EV. Okay, so how could we use triangles to prove that SE is congruent to EV? Talk to your group. Ready to go.
Vertical angle is a property of the rhombus.
So this is a rhombus, right?
Sides of the
Because they're all sides, they all have the
both
same
sides.
side.
And then do vertical angles.
That means all these are congruent.
Similar by
By ASA.
ASA.
So on the first quarter in the game against LT. Vertical
LT?
angles.
Wait,
Yeah.
what day is it?
Right.
I'll pull up.
I think it might be away. It might be an away game.
LT? That's even better.
No, I don't start. Actually, sometimes.
Oh,
I score.
We're all four sides.
better than the starters.
Wait, if it's an away game, it's even better.
Okay, yeah. Okay.
Oh, yeah, they score.
Okay, because in the rhombus, all of the sides are equal or congruent, right?
Who's the LT?
SEP,
Wait, let me see all the LT. Wait,
We
how
play
many?
Emerson tomorrow.
vertical
Wait,
angles.
how many LT?
These
or
two right
LT
here
games
are vertical angles,
There's one
right?
six,
And all of these are
ninth,
congruent. So we can prove that these triangles are here congruent by side equals
the
side.
eighth of them.
Actually, wait, is this just JP?
Where's that?
Oh, good.
Oh, wait, in a rhombus, all the
Wait, can you
sides-
text me what the is? The 9th.
The 9th of February.
Wait, what other side is congruent with though?
We play Emerson.
But are we proving that these triangles are
Let's go to good.
Walnut Grove is really good.
All right, okay, let's talk about this one together. Can someone shout out one thing that you thought could be useful?
Vertical angles.
Vertical angles. Boom. That
Properties of a rhombus.
properties of a rhombus. Which one will we use?
All sides are congruent.
All sides are congruent. There you go. Is that enough to prove that those two triangles on the left and the top are congruent?
Yeah.
Yes. By which theorem?
ASA.
Angle side angle. And so then after that, once those two triangles are congruent, every piece on those triangles has to be congruent to a piece on the second triangle, which is essentially what we're trying to prove. So that's the game plan. So let's go for it. So I'm going to draw my T-chart and write my givens. All right, the first thing we marked was vertical angles. I'll use 3 letters to describe those. So I'll do SEP is congruent to angle VEO by vertical angles. And then we use the property of a rhombus next. So we can say EP, that segment, is congruent to segment EO because all sides are congruent in a rhombus. And then that was enough to prove that those 2 triangles were congruent. So we can say triangle SPE is congruent to triangle VOE by angle side angle. Which means now that the triangles are congruent, segment SE is congruent to segment EV by CPCTC. And that's it. Okay, you guys go ahead and try the last one, and I'll put the solution up on the screen here in a little bit.
We can use diagonals bisect
Now what?
Stop.
to prove it.
But it doesn't say that they
These two are
You can draw Squidward.
And then that's
How?
Oh, no. That's why we have to. That's why they give us that angle. CAB.
Oh, I don't know it's gonna take so long to write it down and prove. You have to prove 2 different triangles are similar.
Oh, yeah, these So other than that, so these 2 are also A. Not like that. No. Yo, stop.
Okay, I won't press it.
Oh,
He likes it.
There is a simpler way, which I will also show you, but that is great.
How do you do it after step 5?
Wow, that took a while.
You're supposed to use it.
No, I'm fine.
Spread the wealth.
So if you can show that the diagonals bind each other, then you can prove that.
Are you ready?
He's coming on to me after he's
I'm for distribution. I'm for security. There's nothing really right.
Whose arm is that?
I just give you.
Yeah, absolutely. Nice.
Because the ultimate angle theorem.
Yeah, wait, you see, look at this. Look at this. I did so much more.
Whoa.
High five.
Yes, thank you.
Let it work.
And units you track.
Oh, yeah. I also work.
What about?
Yeah, you did.
If there's no like actual thing you have to put units.
No, not for star. Like
Units squared 2 per area.
Yeah.
It's only 3.
Your last name's
One of the
Samuel.
whitest
Your
things.
last name's Samuel.
His name's Dustin.
What
And then
about?
application.
Did you plug in like the actual?
No,
X
but
ones? You got it right.
were like the best performance ones.
I was Samuel last time. Yeah, because they all.
Oh my god.
That's ordering a guarantee way to know if you got right or wrong. Huh?
Oh yeah, I remember doing that one. Yeah, I did it for a few. I remember.
We did the right. He just
Oh, okay, I did that.
What?
I feel like I'm
No, he isn't.
The laser?
Yeah, it was like the airport distance.
Oh, it's 7,000.
Yeah, but like.
But now it's 7,000.
Yes.
You're gonna say the bottom.
Time test.
Yeah.
I'll also look at the calendar in a second. Yeah, to remember.
Leo.
All right, guys, real quick, let's talk about this one. Okay, so the easiest way that I found to do this one was to use 7 steps to, well, I feel like pretty much everybody proved that these two triangles were congruent with angle side angle. Did you guys do that? Yeah. So I used CPCTC to prove that BA is congruent to CD. And then, because these angles that it had given me in the given are alternate interior and congruent, I can use the alternate interior angles converse to prove that the lines they're attached to are also parallel. And so then I can use the property of the set of opposite sides are both congruent and parallel to prove that it's a parallelogram. So that's the simplest way I found to do it, but also you can do it in lots of other different ways. Someone else used CPCTC to prove that BE is congruent to ED. And then, whoops, I freeze it again. And then they used vertical angles again. So then they proved the other set of triangles congruent by side angle side. And then they used the opposite sides are congruent to prove a parallelogram, so that would work. Or I also saw someone else use CPCTC to prove that BE is congruent to ED. And then you can say it's a parallelogram because diagonals bisect. So you could do it that way. So there's lots of ways to do it. So I'll leave this up here because this is the way that I saw it first. But if you have another way, just come ask me because there's lots of different ways that you can end up proving it's a parallelogram that are correct.